Marge Ptaszek was searching for the purpose of her life and the truth that would tie everything together to make sense of what was taught and what was happening on our planet, the fire that was creating all the smoke. Through many experiences, she was finally led to the knowledge book that provided all the answers. She is now talking about this gift to humanity on Knowledge Book Radio, so all can be united in peace, love, and harmony. Please call 1-973-787-7035 or email mmjp99@gmail.com with questions. If you send your postal address to mmjp99@gmail.com, you will receive 3 chapters of the Knowledge Book as a gift. Now, here is your host, Marge Ptaszek.
Hello, everyone. I'm Marge Ptaszek, and you are listening to the Knowledge Book Radio with Marge Ptaszek on Transformation Talk Radio. And for the next hour or so that we have available, we will be continuing our series of Omega Talks. Now, these talks are given once a month on the 4th Tuesday at 4 p.m. Pacific Time and 7 p.m. East Coast Time. The talks themselves are part of the unification program of the Call to Friendship Association that's mentioned in the Knowledge Book. So what's happening in these talks is that we connect whatever world knowledge we are emphasizing or putting forth on that day to the Omega dimension, otherwise known as the Union of Central Suns or the 19th dimension. And this dimension, the 19th dimension, actually was part of the knowledge that was given by the New Testament, where it mentioned that I am the Alpha and the Omega. So this is the Omega dimension that we'll be accessing and connecting to. And this dimension up until now has been completely closed to humanity and inaccessible to us. But now, through the Knowledge Book, the world human is able to receive energies and knowledge from the 19th dimension. And one of the topics that we're going to be covering today is about bees. So again, this is the Call to Friendship Association World Unification Program Omega Conference Series for October. And the title is Bees and Consciousness. And my slides are not working. Olivia? Okay. Technical glitch, probably user error. Okay, let's review what we're going to be covering today. Number 1 are bee facts. Number 2, why bees are important. And why is there, and do they have or do they not have consciousness, and how we can check that out. Then we'll be exploring the consciousness of the study of bees. And of course, at the end, we'll have a conclusion and some knowledge from the Knowledge Book. So some of the bee facts, I don't know whether you know this or not, but honeybees live in hives or colonies. The actual members of the hive are divided into 3 types: the queen, the workers, and the drones. And most of the bees that we see are actually the worker bees or the female bees, and they're the ones that are going around from flower to flower. They collect nectar, and they may collect and visit 500 to 100 flowers in one trip. Then they go back to the beehive, deposit the pollen they have collected and the nectar they have collected, and then come back out again to forage some more in the other flowers. And of course, we're seeing less and less of bees because at this point, we have less and less flowers in gardens. We have less and less flowering trees, flowering bushes, and the flowers that bees like to visit. So it'd be good if we started paying attention and planting more flowers for the bees to visit, so they will be able to continue to live and to flourish. Now, the queen bee is the one that's responsible for laying all the eggs for the colony. And this queen bee can lay over 1,500 eggs per day. That's 1,500 eggs per day, which is an amazing number of eggs. There are more than 20,000 different species of bees. They have 5 eyes and 6 legs, so that makes them an insect. And they see all the colors except red. The average beehive can actually hold around 50,000 bees. They fly at about 15 miles per hour or about 25 kilometers per hour. And in 1 second, their wings beat 200 times. So if you say 1,000, that's a second. They've already beaten their wings 200 times in that span of time. And these bees pollinate more than 100 crops in the United States alone. This is just in the United States. So they have played a very vital role in conserving the environment. The recorded history of bees being used in human society goes back as far as 9,000 years. And the evolution of bees dates back hundreds of thousands of years, and they are highly knitted into the environmental development. So when you think about it, bees are the ones that go from flower to flower, or from tree to tree, or from bush to bush, and they pollinate those trees and bushes. If those trees and bushes are nut-producing trees, or berry-producing bushes, or fruit and vegetable-producing plants, the bees then allow those plants to continue to grow and to produce the next generation of that plant. Whether that next generation is stored as a seed or inside of a nut kernel, this is how the bees are able to help us to survive. And of course, all those beings who need either the nuts, the berries, the fruits, the grass, whatever it is, to be able to survive, the bees actually provide the means for that to happen. So get rid of the bee and you get rid of the entire food pyramid. So why are they important? So basically, they're the most important pollinators known to humans. Although there are pollinators that are other insects or moths or butterflies, the most important pollinator are actually bees. They're the only insect that is able to provide honey, provide beeswax, and actually that's a renewable fuel source. They pollinate and allow for the growth and development of crops and various other essential aspects of nature. So we wouldn't have oak trees if there aren't oak flowers, which then are pollinated. There are lots of species of bees and honeybees found all over the world, and even many undiscovered species exist today. However, I don't think if I remember correctly, it is the wind that actually cross-pollinates oak trees through the catkins. However, bees play an important part in the food bases that we actually use to be able to survive and live. So why are the bees important to the environment? Well, number one, if the bees are sick, the environment is also sick. So nature is also sick. There are natural barriers to crop fields. They're the most beneficial pollinator. They're basically sustaining the food pyramid. They contribute to the economic status of the country or the world. They actually contribute to science, contribute to biodiversity. So if there's a new species that is developed, if the bee pollinates this new species of plant, then it means it allows that plant to survive and to continue to the next generation and the next generation, which means they are allowing that new species of plant to survive and grow and develop more. And they're actually the ones who are natural forest formations. So they allow the forest to exist as well. Okay, we've covered the fact that they're important and they do a great job in pollinating and producing honey, but are they conscious? Now, experiments indicate that bees have surprisingly rich inner worlds. In other words, they could be conscious. Now, the French philosopher René Descartes, whose views on animals were highly influential, well, he said that these creatures acted purely on reflex. They had no intellectual capabilities. But, so in talking about reflex, that's like when you put your finger in a flame, you automatically, the arm itself just jerks back. You have no control over that action. Conscious action means that you're taking your hand and picking something up off the floor because you're controlling that action through your motor activity and your intent. But finger in a flame, finger in an electric socket, you automatically jerk back, and that jerk back is a reflexive action. But there has been a Copernican revolution since then. In other words, we now consider bees not to be just reflective, intuitive individuals or species. If you remember, Copernicus was the one who literally turned the world upside down or inside out, as it were. Basically, Copernicus at the time he's the one that said that the sun and the planets revolve around the earth. Sorry, that's backwards. At the time of Copernicus, the ruling knowledge at the time was that the earth and human was the center of the universe and everything else revolved around it. The sun, the planets, everything. And they created all kinds of structures and forms to show how and explain how the motion of the stars that they were seeing at night were represented by the fact that the earth was standing still and everything else was revolving around it. So he stood this on end and said, no, it is the earth that revolves around the sun, and the sun is the center, and all the planets, including Earth, spin around the sun. So this is complete flip. And right now we're also completely flipping our thinking about bees. And we're now discovering that bees have sophisticated minds, and other animals too have sophisticated minds, not just humans or chimps or apes, which are our closest relatives in a sense. And even an octopi or octopuses, as it's commonly known, have consciousness and are intelligent. So now we're also learning how smart insects can be. So the latest research actually shows that even tiny brain bees are profoundly intelligent creatures that can memorize not only flowers, but also human faces. They're able to solve problems by thinking rather than by trial and error, and learn to use tools by observing skilled bees. So they basically show they are able to learn behavior by copying someone else or some other bee's behavior. And now it's been shown that they even appear to experience basic emotions, or at least something like optimism and pessimism. So it is possible that these bees are sentient beings. And because that is the possibility, that means we have an ethical question, an ethical subject for ecological conservation, as well as their treatment in the crop from pollination industry and in research laboratories. So we would tend to We need to make sure that we are treating the bee as a sentient being and therefore give it the honor and respect it deserves, they deserve. Now, social insects are traditionally thought to be wholly governed by instinct. They can build complex nests and efficiently divide up their labor through innate behaviors, but are considered stupid as individuals, with complexity emerging only at the group level. So it's only when they get together with other bees or other insects that they're considered to be intelligent or able to solve problems. But there is significant evidence that bees have an inner world of thought, that they are not responding to stimuli only with hardwired responses. So our jerking away from heat, away from electricity, is a hardwired response. We have no control over it. So bees are not hardwired that way. Now, what do they do? How does this tested in bees? In order to explore bees' learning abilities, scientists basically reward them with a little drop of sugar water when they have solved a task. And this is the same reward that bees obtain in nature when they discover a nectar-rich flower. For example, to probe bees' phase recognition skills, foragers or forager bees were first rewarded with sugar water on a platform in front of a black and white photo of a human face. Once they learned to fly to this platform, they were confronted with a test in which they had to locate the correct photo out of a number of images of other people. No rewards were now present, and the correct photo was located in a different position during this test. Nonetheless, they found the correct face over 80% of the time, lending credence to the common beekeeper's assertion that bees can recognize the person who looks after them. So now the scientists wanted to figure out whether the bees can count. Of course, we've seen where animals and horses and crows are able to count or shown to be able to count. But now they figured insects, they're lower down on the evolution scale, much lower than the mammals. So maybe can they or can they not count? So the scientists trained the bees to fly from their hive past 4 identical landmarks. Each one of those landmarks was an 11-foot high pyramid. And during the training, they only found the sugar reward, the sugar liquid, after the 3rd landmark. And in the test, what they did was they increased the number of landmarks. So instead of 4, they may have 6, they may have 7, between the hive and the training location of the feeder. When they did this, bees landed at a shorter distance from the hive than during the training, apparently thinking that they had flown far enough when they encountered the 3rd landmark. And if they reduced the number of landmarks, when they reduced the number of the 11-foot pyramids, they maybe had 2 pyramids. The bees basically went further than the 2, looking for the 3rd to seek the 3rd landmark. So it appears that bees can count. They are looking for the 3rd pyramid and try to find it no matter how many pyramids or how many landmarks they have in place. They could also access memories. Now, if you remember Marcel Proust, in his book, Remembrance of Things Past, how one person, after they tasted tea-soaked madeleines, they suddenly recall a long-lost childhood memory in vivid detail. I'm sure that everyone has remembered when they heard a specific song as to you're immediately transported back to the time when that song was being played. When they encounter a certain aroma, a certain smell, they go back to the time and the place and they remember what's been going on at the time, whether that's a good memory or not so good memory. So it turns out that the bee is able to do the same thing. So a scent experienced by a bee inside the hive can bring back the memory of a flower patch with the same scent. To show this, to demonstrate this, scientists first trained bees to memorize two different feeding locations about 55 yards from the hive and 33 yards apart, one smelling of rose and the other of lemon. When researchers blew one scent or another into the hive, it activated the bee's memory of the correct feeding station, and they flew directly to that feeding station. So the scent of the lemon or the scent of the rose, the bees had that in their memory, they recognized it, and they went to the feeding station that actually had that smell. So the memories of bees, just like humans, can be activated separately from the setting in which they are learned. So if they may learn one thing in one place, however, they have been everywhere, but they somehow are able to remember where that scent was and where it came from and are able to locate it afterwards. They could do this also in darkness, because the hives are dark at night, and actually they're dark during the day as well. And they communicate with other bees about them. So bees have a dance language by which they can inform others in the hive of the precise location of a rewarding flower patch. So maybe a bee found a particular garden or particular field that has lots of flowers in bloom at that time. And basically, in all excitement, they come back to the hive and tell all the other bees, listen, guys, there's a tremendous amount of flowers here, very good nectar. Come on, let's go, so we have some more nectar to bring back. Now they have this, and they tell the other bees through a symbolic language that involves repeating motor patterns or dances of a knowledgeable bee on the vertical honeycomb. The movements themselves, basically their symbolic language, they refer to gravity and the direction of the sun. And since it's dark in the hive, bees that want to learn from the dancer, actually they need to touch its abdomen with their antennae, and that's how they know what the symbol that the bee is trying to communicate. Sometimes such dances are displayed at night when there is no foraging taking place, because the bees come back to the hive at night. So the dancer appears to be thinking about locations visited on the previous day without an obvious need to do so at the time. And that indicates that memories can be browsed in an offline situation, meaning they could go back and think about the locations that they had found previously and is able to communicate it from memory and not from, I mean, it is both from memory, but this is that immediate need memory. And they also they can picture things in their minds. Bees that first learn that balls, but not cubes, are linked to sugar reward by seeing these shapes through plexiglass. In other words, they can't touch them, they can't fly around them, but they can only see these shapes. And when they see this shape, they get a sugar water reward. And they can actually identify the same shape by touch alone. So somehow they're able to transform the visual signals and be able to recognize the same shape through touch. The scientists tested this in darkness, and they viewed the bees' behavior with infrared equipment, meaning it's dark, but infrared technology, basically, there is special equipment that can actually sense it. This is warmth. Infrared is like lower scale red frequency. So they basically can work in infrared frequencies because they're usually in the dark as far as their hives are concerned anyway. So bees that are trained to tell cubes from spheres in darkness could also later identify the correct shapes when seeing but not touching them. So they could identify the same subject, the same shape, both through touch and through sight, without actually seeing them directly or experiencing them directly through some kind of direct physical experience. And therefore, they're actually able to have a mental image that can be accessed with more than one sense. So both sight and touch here. Well, believe it or not, bees can also solve problems. And they do this in a way that shows they understand the desired goal. There was one experiment where bees learned to roll a ball to a certain area to obtain a sugar reward. And this is considered a simple form of tool use. So an object needs to be manipulated in a specific way, and that's what's called a tool. Untrained bees then improved the technique. A trick was played on the demonstrator bee so that only the farthest of 3 balls could be moved to the target area. The 2 other balls were glued to the horizontal surface. A naive bee, basically one that has not experienced this experiment, but that bee was allowed to see what the other bee was doing. In other words, the other bee was actually rolling the ball, the 3rd ball, into the goal. So when the bee observed this, when its turn came to roll the ball, at that time, all the balls were free to move. So that bee took the first ball that it encountered and put it back into the goal. And they did this 3 times. So the bees are able to watch another bee, watch another process, and able to mimic it. In other words, they're able to learn behavior from others' behaviors. Now, when the observer was subsequently allowed into the arena alone, now finding none of the balls glued down, it actually, without any trial and error, picked up the closest ball to move to the goal. And therefore, they solved the task in a way inspired by the demonstrator, but clearly not merely imitating its performance. So it didn't go to, if that watcher bee or observer bee would duplicate the action of the previous or the trained bee, then they would have gone for the 3rd ball and put that in the goal. However, this observer bee was able to understand that the goal of the objective of the whole thing is to get the ball into the goal, and it took the 1st ball and put it to the ball. And this actually indicates, according to the scientists, a form of intentionality that was previously recognized only in large brain animals, such as chimps, apes, and of course humans. We could also ascribe this behavior to animals as well. We can attest to cats' behavior and dogs' behavior as well. Now, since we've covered all of this, now it turns out the bees can have, and they have shown evidence of having emotion-like states. And they use the same criteria that researchers deployed to evaluate whether domestic animals such as goats or horses are being kept in conditions that result in a positive or negative outlook on life. So they trained bees to learn that blue was rewarding and green was not. And another group of bees was trained with completely the opposite conditions, so that green was rewarding and blue was not. And afterwards, they presented those bees with an intermediate color, turquoise, and that's an ambiguous stimulus. Crucially, the bee's judgment of this ambiguous color depended on what happened before the experiment. Unexpected rewards before the test appeared to induce an optimistic state of mind in bumblebees, making them more curious about new stimuli and more resilient to reverse stimuli. This optimistic state relied on the neurotransmitter dopamine, as it does in humans. So bees could have moods too, or experience moods. Now you could also induce a negative emotional state in the bee by having the bee attacked. Now, some species of spiders sit on flowers and try to catch pollinating insects. They recreated this in the lab, constructing a plastic spider with a mechanism by which a bumblebee was momentarily held between two sponges and then released. And afterwards, the bee's behavior changed fundamentally. They seemed more nervous for days after this attack. And beyond the simple learned aversion to flowers with artificial spiders, they extensively scanned every flower before landing, even if there were flowers without a robotic spider. They sometimes fled as if they were seeing ghosts, meaning maybe a shadow reminded them of the darkness of the spider and they didn't want any part of that flower. The bees behaved as if they were suffering from post-traumatic stress disorder. Now, people who criticize and still want to believe that insects and bees are not conscious and they cannot do all this, and they believe that this is all behavior, all instinctive behavior, they will say that each of these abilities could be programmed into a non-conscious robot. Well, that critical person could be correct or would be correct, but such a robot would often fail at tasks that a programmer did not build into it. In other words, the robot can only do what the program tells it to do. However, the bee is able to learn and to make decisions and to be able to teach as well and to communicate as well. So a robot that was built 20 years ago to replicate all the skills of a honeybee, as understood at the time, will not have been able to exhibit the abilities of the bees that were more recently discovered, to be able to roll a ball to a goal, to recognize shapes across senses, or display emotion-like states. Nature has no room to generate beings that just pretend to be sentient. Thus, while there is no accepted formal proof for consciousness in any animal or machine, common sense dictates that growing evidence of consciousness does indeed indicate what it seems to show. So the insight that bees have a rich inner world and unique perception and, like humans, are able to think, enjoy, and suffer commands respect for the diversity of minds in nature. With this respect comes an obligation to protect the environment that shaped these minds. And actually, one of the things that is part of becoming a genuine human, is part of being accepted as a genuine human, is the respect and care for nature and all the beings in nature. So now we're going to take a little bit different angle. Bees display a remarkable range of talents, abilities that in a mammal, such as a dog, we would associate with consciousness. So people, humans, take the magical gift of consciousness for granted. From the time that we wake up in the morning until the time that we fall, hopefully, into a dreamless sleep, we are flooded with conscious sensations. And contrary to the assertions made by philosophers, novelists, and other literati, by and large, this stream of consciousness does not relate to quiet self-reflection and introspective thoughts. Most of it is filled with raw sensations. We go from perception to perception, to reactions to those perceptions, and on and on. So is there such a thing as animal consciousness? So this is not so dissimilar to the way animals consciously experience their world. In other words, the animals too will have a running stream of perceptions, whether through all the senses. Except for maybe the great apes and a few other privileged big brain animals, most species do not possess the highly developed sense of self, the ability to reflect on oneself that people have. Most biologists and pet owners are willing to grant consciousness to cats, dogs, and other mammals Yet our intuitions fail us completely when we consider fish and birds, let alone invertebrates such as squid, flies, or worms. Do they experience the sights and sounds, the pains and pleasures of life? Surely they can't be conscious. They look too different from us, too alien, meaning the closer that being in nature looks like us and functions like us, the more we're able to attribute consciousness to them. But the further down the evolutionary ladder that a particular being exists, we tend to think that they are, number one, stupid, and they're just basically following their instincts, and they are not conscious. Now, insects especially were long thought to be simple, reflexive creatures with hardwired instinctual behaviors. But that is not the case anymore. So we're going to look again at the amazing capabilities of the honeybee, otherwise known as the Apis mellifera. So we have short-term storage of symbolic information. So just like when we put in a telephone number into our cell phone, that cell phone retains that information, and our brains, when we get a piece of knowledge or piece of information, we store that in our brain as well. So this is part of what is considered conscious processing. So can bees remember task-relevant information, and therefore can they be conscious? Now, studies showed that yes, they do store and they have consciousness. So Martin Gerfa of the University of Toulouse in France, and Mandyam Srinivasan and Sharu Zhang, both at the Australian National University in Canberra, trained free-flying bees, say that 10 times quick, trained free-flying bees using a sugar water as a reward in a variety of complex learning tasks. The neuroethnologists taught the bees to fly in and out of a tall cylinder with one entryway and two exit holes. Each bee had to choose one of two exits to leave the cylinder and to continue her flight. Although these experiments do not tell us that bees are conscious, they caution us and warn us that we have no principal reason at this point to reject the idea. Bees are highly adaptive and sophisticated creatures with a bit fewer than 1 million neurons. And these neurons are interconnected in ways that are beyond our current understanding. They're jammed into less than 1 cubic millimeter of brain tissue. So we're talking 1 million neurons connected differently than our brain is connected, and they're jammed into, I guess, a dot, which is amazing. So this neural density in the bee's brain is about 10 times higher than that in a mammalian cerebral cortex, which most of us take to be the pinnacle of evolution on this planet. In humans, widespread loss of cerebral cortex leads to an irreversible loss of consciousness. That is not to say that a cerebral cortex is necessary for consciousness in creatures with a different evolutionary heritage. So it is possible that consciousness is present in a different species, in a different type of being with a different neurological wiring. And to think that the density of the bee's brain is 10 times higher than human or mammalian brains, it's amazing. The bees themselves live in a highly stratified yet flexible social organizations with group decision-making skills that can rival academic, corporate, or government committees in efficiency. Though, of course, if you want to lose something, you put it into committee, and there's always discussion, and not much advancement and decisions going on. So in the spring, the bees need to find a new home, and they need to find a new hive as a community, and they need to satisfy their needs with demand within a couple of days. So they all need to go out there, find something that is a good new hive location that will have, I guess, protected environment, connection to and proximity to feeding locations, flowers, fields of flowers and such. So when the bees go out and look for these locations, they come back to the hive and they start the waggle dance to communicate to the other bees as to what they found and where they found it. Now the bees can fly several kilometers and return to their hive. And actually that's a very remarkable navigational, performance. There was a time that I could be given instructions on how to get somewhere, and I would go there and back based on instructions, and I would remember what to do the following time I went. However, currently I need at least 3 times to follow the same instructions to be able to come back and go there and come back again without getting lost. So the bees are better than me at this point in order to find a location, go there and come back. So it looks like they have their own GPS system in their brains that allows them to do that. And they have a map of their environment. And when a scent is blown into the hive, that triggers a return to the site where the bee previously encountered this scent, this odor. So given all this ability and capability, why does almost everybody instinctively reject the idea that bees or other insects might be conscious? Well, the trouble is that bees are so different from us that our insights fail us. But just because they are small and live in colonies does not mean that they can't have subjective states, that they can't smell the fragrance of the golden nectar or experience the warm rays of the sun, or maybe even have a sense of self. Now, in the Oxford Language Dictionary defines consciousness as the state of being awake and aware of one's surroundings, the awareness or perception of something by a person, the fact of awareness by the mind of itself and of the world. And based on the information presented and this definition, it could be argued very easily that bees are conscious beings, that they are indeed conscious. When we go to the knowledge book, the glossary states and has the following definition, quote, consciousness, to comprehend, to get a grasp of something. Consciousness of truth, to become cognizant of the cause of existence of the individual, to awaken, to become conscious, end quote. Knowledge book, fascicle 37 continues. Humanity will first attain its own consciousness, later will settle in unity consciousness, and only afterwards will integrate with the universal ordinance. And if you're looking for the definition of unity consciousness, it is in the glossary, and it is unity to become oneness. So we start our journey, our evolutionary journey, with our ego in control to protect ourselves, to guarantee our continued survival. We'll step on others, we'll walk over others to be able to protect ourselves, for us to have the means to living and to continue living. However, the description of a person who is conscious is given in fascicle 39. Quote, a person who has genuine consciousness should think of others rather than himself, herself. This is what is meant by altruism, and it is not gained easily. This is a matter of evolution, end quote. So the higher up the evolutionary ladder you go, the more altruistic you will be, and the less ego you will have. And that's actually the measure of where we stand on the evolutionary scale. Are we still ego-driven, or do we care about others and make sure that everyone else, including us, is able to survive and continue living? In fascicle 49, quote, during the difficult days of these difficult conditions experienced, You catch the light of happiness as much as you reach the unity consciousness, and you abandon individual actions. End quote. So we're all going through difficult times. All kinds of situations are arising very quickly and all over the place and everywhere. So if you want to be able to be happy, as long as we're able to go to unity consciousness, then we'll be, of course, being happy. And when we abandon individual actions basically are ego-driven and self-serving, not serving the totality. Okay, so it's easy to say, okay, fine, evolve. But how do you do that? What is there that we need to do to be able to accomplish this? Well, part of the answer is given in Fascicle 41. Quote, the knowledge book is not for the individual satisfaction of a certain mass of people, but is a book carrying the entire responsibility of your planet and of the world of the morrows. In this step, you will take forward on this path. 1, first, grasp the truth. 2, then attain the consciousness of what to do. 3, and then convey the truth to humanity. 4, the fascicles of the book create a purification medium that 1,000 world humans cannot create. 5, from now on, stop acting according to your individual consciousnesses. So basically, end quote. Basically, we need to decide what to do and how to do it, and then go ahead and do it. So I'll repeat again. First, grasp the truth, then attain the consciousness of what to do, and then convey the truth to humanity. The fascicles of the book create a purification medium that 1,000 world humans cannot create. Now we know from information on the internet, information that has been provided and based on scientific experiments, that the more people in a group, the more people are focused on a particular object in the meditation, the greater the effect of that meditation. Meditation, sorry. And that has been tested. And the more meditators in a place, the more unified they are, they're able to affect larger and larger population. However, one fascicle of the knowledge book creates a purification medium that 1,000 world humans meditating cannot create. So this is the power of the knowledge book. This is why it is so important to read it, to get it, and work with its programs. And again, the emphasis is stop working based on individual consciousnesses, based on your own personal self-serving, ego-driven intention. So here's an interesting comparison. When we make decisions, our brains are abuzz with agreements and vetoes. So you've got all kinds of ideas. One idea comes up, it gets shut down. Another idea comes in, that gets shut down. All kinds of conflicting, this and that, if this, if that, if the other, this will cause this, the other will cause something else. So groups of neurons represent different choices and interact with one another until one rises to the fore. So eventually the neurons excite some of their neighbors into firing in tandem, or suppressing others into silence. From this noisy crosstalk, a choice emerges. We made a decision as to what to do. Now, the same thing, interestingly enough, happens in a beehive. The entire colony, consisting of tens of thousands of individuals, works like a single human nervous system, with each bee behaving like a neuron. When they make a decision, such as choosing where to build a nest, individual bees opt for different choices, and they support and veto each other until they reach a consensus, which is amazing. Honeybees selflessly work for the benefit of the entire colony. Scientists refer to them as a superorganism, which in simple terms means that many little critters act as one. One colony, thousands of honeybees, one goal, to ensure the survival of the colony. Actually, we have the same obligation. We are one human species. We have one world, and we are responsible for making sure that that exists. And okay, now it's almost time to stop. Conclusion. We've run out of time. Once we finish our evolution, accelerated and helped by the energies and the truth contained in the knowledge book, we will have attained the state of the consciousness of the honeybee, where we will serve the totality and not ourselves. So again, once we finish our evolution, accelerated and helped by the energy and the truth contained in the knowledge book, we will have attained the state of the consciousness of the honeybee, where we will serve the totality and not ourselves. So maybe when our neuronal density approaches that of the honeybee, we'll become more and more conscious and more altruistic, and therefore be able to succeed in our evolution. So I'd just like to remind you that the United States website is USA, www.usa.theknowledgebook, all one word, .net. The Call to Friendship website is www.calltofriendship.org. And the Turkish website, the main website is www.dkb-mevlana.org.tr. My phone number for questions and email number for questions or suggestions of topics or discussion points is 973-787-7035. And the email is mmjp99@gmail.com. That's Mary John Peter 99@gmail.com. So hopefully next time we'll get together again and spend some time together. In the meantime, stay well. All the best. Take care.
You've been listening to Knowledge Book Radio with Marge Ptaszek. Marge was led to the Knowledge Book, a gift to humanity at its time of transition to the Golden Age that provides the truth, energies, and knowledge. Now she shares information from and answers questions about the Knowledge Book with you the fourth Tuesday each month at 4 p.m. Pacific, 7 p.m. Eastern on TransformationTalkRadio.com. For more information, visit usa.theknowledgebook.net and tune in next time for another amazing show on Knowledge Book Radio.